Continuing with Pythagorean theorem. I know Pythagorean theorem, I told you guys that it works as long as the angle at the corner is 90 degrees. So we call that a right triangle. And I know Pythagorean theorem, I told you guys yesterday, is a squared plus b squared equals c squared, where c is the biggest of the three. Which one is a, which one is b? Those two doesn't matter, as long as c is the biggest one. Now my question for the first four is, do the following lengths form a right triangle? So what I'm asking you is a squared plus b squared equals to c squared? Like a yes or no type of question. Here, c is 13, that's the biggest. So let me write 5 squared plus 12 squared equals 13 squared, right? I'm checking if it's true or not. I know 5 squared is 25, 12 squared is 144, and then 13 squared is 169. Since 25 and 144 are combined, together I can combine them. 25 plus 144, that is 169. On the other side I have 169. So my question to you now is 169 equals 169? Yes. So in that case, yes, it is a right triangle. It will be a no if at the end I have two different numbers. Then no, it's not a right triangle. So the first four, that's what I'm looking at. It's like a yes or no type of question. Now for number 5, I'm giving you guys an angle that's 90 degrees, right? I'm representing with the box. And I'm asking you, find the missing length. So let me call this side A, because I know 7 is the biggest, so that's C. Now from these two sides, one is A, one is B. I'm going to call that one A. So let me write a squared plus 2 squared is equal to 7 squared. So we have that a squared plus 4 is equal to 49. Since the 4 and 49 are not together, there's an equal sign in between them. Let me move the 4 to the right. I'm going to switch the sign. So now it's minus 4. So I have that a squared is 45. That means that a is the square root of 45. Simplify your radical. I know for 45, I'm thinking this as 9 times 5. 9, I'm thinking of 3 times 3. 3 is a group, 5 is a single. Groups go out, singles stay in. So a is 3 radical 5. Simplify your radicals. Let's take a look at question number 6. The biggest side here is 13. So let me call this side, I can call it either A or B, it doesn't matter. So I have a choice, let me call it A, just because I can call it A or B. So I'm going to go a squared plus 9 squared is equal to 13 squared. That means that a squared plus 81 is equal to 169. Once again, since the numbers are not together, I have to put them together. So I'm going to move the 81 to the right as a minus 81. So I have that a squared is equal to 88. So that means that a is the square root of 88. Simplify your radical. Break this as 8 times 11. Let me break this as 4 times 2. Let me break this as 2 times 2. So there's a group, and there are 2 singles. So A will be 2 radical 22. Right. Since there were 2 singles, I multiplied it to put them inside. So that's how I got the 22. Remember, if there's more than one single, multiply them. The same thing with groups. If there's more than one group, multiply your groups. Let me do one more question. Let's take a look at number 7. Now here, the biggest side is C, which is what we're missing. So I'm going to call that C. Right, now we're missing the biggest side. So I'm going to go 9 squared plus 12 squared is equal to c squared. That means that 81 plus 144 is equal to c squared. Now 81 and 144 are together, so I can just combine it. 81 plus 144, that is 225. So I know that c is equal to the square root of 225. I'm going to think of two numbers that multiply equals 225. I'm going to go 15 times 15. I know I can break my 15s as 5 and 3. But then it will be two groups, and when I multiply my groups, it's going to bring me back to 15. So I'm not going to break it up. So in this case, c is 15. There's no radical because there are no singles, right? Everything got in a group.